The first part of laboratory course is devoted to the study of microprocessor systems. The main component of practical training will be the use of the AVR V7 debug training kit. Consider the structure of the kit. Dual power supply. Board contains switching power supply that creates stable voltage and current levels necessary for powering each part of the board. Power supply section contains two power regulators, ST1 S10, which generates VCC 5 volts, and MC33269 DT 3.3, which creates VCC 3.3 volts power supply. The board can be powered in 3 different ways: with USB power supply, CN1, using external adapters via adapter connector CN24, or additional screw terminals CN25. External adapter voltage levels must be in a range of 9 to 50 volts DC or 7 20 volts IC. Use jumper J22 to specify which power source you are using, and jumper J5 to specify whether you are using 5 volts or 3.3 volts power supply. Upon providing to power using either external adapter or USB power source, you can turn on power supply by using switch 1. Power LED green on will indicate the presence of power supply. To power the board with USB cable, place jumper J22 in USB position and place jumper J5 in 5 volt or 3.3 volt position. You can then plug in the USB cable as shown on image and turn the power switch on. Supported microcontrollers. The board contains 7 deep sockets: deep 40A, deep 40B, deep 28, deep 20A, deep 20B, deep 14, deep 8, with dual power supply and smart onboarding microprog. The board is capable of programming about 65 different microcontrollers from ATMEL AVR family. There are 2 deep 14 and deep 20 socket for AVR microcontrollers provided on the board. Which of these sockets you will use depends solely on the pinout of the microcontrollers in use. The AVR V7 development system comes with the ATmega 32 microcontrollers in the deep 40 package. AVR microcontrollers can use either built-in internal or quartz crystal external clock for the purpose of providing clock signal source. The AVR V7 contains one quartz crystal socket for all microcontroller sockets. The value of the quartz crystal depends on the maximum clock frequency allowed in your application as well. You can always replace the default 8 MHz crystal with another one. If you want to use microcontrollers and deep 40A and deep 40B package, it is necessary to place jumper J30 to J70 into the IOO position. Onboard programmer. Microprog is a fast USB 2.0 programmer. Smart engineering allows Microprog to support about 65 AVR microcontrollers for ATMEL in a single programmer. Outstanding performance and easy operating are among its top features. Free LEDs indicate specific programmer operation. Link LED lights up when USB link is established with UPC. Activate LED lights up when to programmer is active. Data is on when data is being transferred between the programmer and PC software, compile or AVR flash. In order to start using microprog and program your microcontroller, you just have to follow two simple steps. 1. Install the necessary software. Install USB drivers. Install AVR flash software. 2. Power up the board and you are ready to go. Plug in the programmer USB cable. Link LED should light up. Input-output group. One of the most distinctive features of Easy AVR V7 are its input-output port groups. They add so much to the connectivity potential of a board. Port headers, port buttons and port LEDs are next to each other and grouped together. It makes development easier and the entry Easy AVR V7 cleaner and well organized. We have also provided an additional port headers on the left side of a board, so you can access any pin you want from both sides of the board. Free state pull up, down deep switches. Free state deep switches like SW1 on are used to enable it 4K7 pull up or pull down resistor on any desired port pin. Each of the switches has three states. 1. Middle position disables both pull up and pull down feature from the port pin. 2. Up position connects the resistor in pull up state to the selection pin. 3. Down position connects the resistor in pull down state to the selected port pin. Buttons. The logic state of all microcontroller digital inputs may be changed using push buttons. Free state deep switch SW1 is available for selecting which logic state will be applied to corresponding MCU pin when button is pressed for each E and O port separately. If you, for example, place SW1.2 in VCC position, when pressing any of push buttons in port B, E and O group will apply logic N to the appropriate microcontroller pin. The same goes for G and D. If deep switch is in the middle position, neither of two logic state will be applied to the appropriate microcontroller pin. You can disable pin protection 220 ohm resistor by placing jumper J1 and J2, which will connect your push button directly to VCC and GND. Be aware that doing so you may accidentally damage MCU in case of wrong usage. Reset button. In the far upper right section of a board there is a reset button which can be used to manually reset the microcontroller. Board contains 35 LEDs which can be used for visual indication of the logic state on port pins and activate LED indicators that a logic high is present on the pin. In order to enable port LEDs, it is necessary to enable the corresponding deep switches on SW10. ADC inputs. Digital signals have two discrete states, which are decoded as high and low and interpreted as logic 1 and logic 0. Analog signals, on the other hand, are continuous and can have any value within defined range. A and D converters are specialized circuits which can convert analog signal voltages into a digital representation, usually in form of an integer number. The value of this number is linearly dependent on the input voltage value. Most microcontrollers nowadays internally have A and D converters connected to one or more input pins. Some of the most important parameters of A and D converters are conversion time and resolution. AVR V7 provides an interface in form of two potentiometers of simulating analog input voltages that can be routed to any of the 20 supported analog inputs pins. LCD 2 on 60 characters. Liquid crystal displays or LCDs are cheap and popular way of representing information to the end user of some electronic device. Characters LCDs can be used to represent standard and custom characters in the predefined number or fields. AVR V7 provides two connector and the necessary interface for supporting 2 on 60 characters LCDs in 4-bit mode. This type of display has two rows consisted of 60 characters fields. Each field is a 7 on 5 pixel matrix. Communication with the display module is done through display connector. Board is fitted with an equally designed plastic display dispenser, which allow the LCD module to perfectly and firmly fit into place. For digit 7-seg display. On 7-segment digit consists of 7 plus 1 LEDs which are arranged in specific formation which can be used to represent digit from 0 to 9 and 11 some letters. One additional LEDs is used for making the decimal dot in case you want to write a decimal point in the desired segment. AVR V7 contains 4 of the digits put together to form 4-digit 7-segment display. Driving such a display is done using multiplexing techniques. Data lines are shared between segments and therefore the same segment LEDs in each digit are connected in parallel. Each digit has its unequal digit select line which is used to enable the digit to which the data is currently being sent. By multiplexing data through L4 segment fast enough, you create an illusion that all 4 segments are in operation simultaneously. This is possible because human ear has a slower reaction time when the mentioned changes. This way you can represent numbers in decimal or hexadecimal form. 8 data lines that are common for all the digits are connected to port C, and digit select lines are connected to PA0 and PA3 lines on the microcontroller circuits. Word via RS-232. The word Universal Asynchronous Receiver Transmitter is one of the most common ways of changing data between the MCU and peripheral components. It is a serial protocol with separate transmit and receive lines, and can be used for full duplex communication. Both sides must be initialized with the same baud rate, otherwise the data will not be received correctly. Enabling RS-232. In order to enable RS-232 communication, you must set J23 and J20 jumper in this RS-232 position and enable desired RX and TX lines via SW10 deep switch. For example, if you want to enable RS-232 connection on word model of a default Atmega 32 chip, you should enable SW10.1 RD0 and SW10.2 RD1 lines. Word via USB. Modern PC computers, laptops and notebooks are no longer equipped with RS-232 connectors and word controllers. They are nowadays replaced with USB connectors and USB controllers. Still, certain technology enables word communication to be done via USB connection. FT232RL from FDTI convert word signals to the appropriate USB standard. In order to use USB word module on Easy AVR V7, you must first install FDTI drivers on your computer. Drivers can be found on product DVD. Enabling USB word. In order to enable USB word communication, you must set J23 and J20 jumper in the USB word position. In enable desired RX and TX lines via SW10 deep switch. For example, if you want to enable USB word connection on word module of the default Atmega 32 chip, you should enable SW10.1 RD0 and SW10.2 RD1 lines. DC1820 digital temperature sensor. DC1820 is a digital temperature sensor that uses one-wire interface for its operation. It is capable of measuring temperature with the range of -55 to 128 degrees Celsius and provides ±0.5 degrees Celsius accuracy for temperatures within the range of -10 to 85 degrees Celsius. It requires 3 volts to 5.5 volts power supply for stable operation. It takes maximum of 750 milliseconds for the DC 1820 to calculate temperature with 9-bit resolution. One-wire serial communication enables data to be transferred over a single communication line, while the process itself is under the control of a master microcontroller. The advantage of such communication is that only on microcontroller pin is used. Multiple sensors can be connected on the same line. All slave devices by default have a Anywhere ID code, which enables the master device to easily identify all devices sharing the same interface. AVR V7 provides a separate socket TS1 for the DC 1820. Communication line with the microcontroller is connected via jumper J18, enabling DC 1820 sensor. AVR V7 enables you to establish one-wire communication between DC 1820 and the microcontroller via PB4 or PA7 microcontroller pins. The selection of either of full two lines is done using J18 jumper. When placing the sensor in the socket, make sure that half cycle on the boards silkscreen making matches the rounded part of the DC 1820 sensor. If you accidentally connect the sensor the other way, it may be permanently damaged. Make sure to disconnect other peripherals except one wire, LEDs and additional pull-up or pull-down resistors from the interface lines in order not to interfere with signal or data integrity. LM35 analog temperature sensor. The LM35 is a low-cost precision integrated circuit temperature sensor whose output voltage is linearly proportional to the Celsius centigrade temperature. The LM35 thus has an advantage over linear temperature sensor calibrated in degree Kelvin, as the use is not required to subtract a large constant voltage from its output to obtain convenient centigrade scaling. It has a linear plus 10 mV per degree Celsius scale factor and less than 60 microampere current drain. As it draws only 60 microampere from its supply, it has very low self-heating, less than 0.1 degree Celsius in still air. Is AVR V7 enable you to get analog reading from the LM35 sensor in restricted temperature range from plus 2 degree Celsius to plus 150 degree Celsius. Both provides a separate socket TS2 for the LM35 sensor in TO92 plastic packaging. Reading add-on with microcontroller using single analog input line, which is selected with jumper J19. Jumper connectors the sensor with either PA7 or PB4 microcontrollers pins. Easy AVR V7 enables you to get analog reading from the LM35 sensor using PA7 or PB4 microcontroller pins. The selection of either of whose two lines is done using J19 jumper. When placing the sensor in the socket, make sure that half circle on the board's silk screen making matches the rounded part of the LM35 sensor. If you accidentally connect the sensor off a way, it can be permanently damaged, and you might need to replace it with another on. During the reading of the sensor, make sure that no other device uses the selected analog line, because it may interfere with the readings. I2C EEPROM. EEPROM is short for electrically erasable programmable read-only memory. It's usually a secondary storage memory in devices containing data that is retained even if the device loses power supply. Because of the ability to alter single byte of data, EEPROM devices are used to store personal preference and configuration data in a wide spectrum of consumer, automotive, telecommunication, medical, industrial, and PC applications. AVR V7 supports serial EEPROM, which uses I2C communication interface and has 1024 bytes of available memory. Board contains socket for serial EEPROMs in deep 8 packaging, so you can usually exchange it with different memory size EEPROM IC. EEPROM itself supports single bytes of 16 bytes page write and read operations. Data rate is 400 kHz for both 3.3 volts and 5 volts power supply. Enabling I2C EEPROM. In order to connect I2C EEPROM to the microcontroller, you must enable SW5.7 and SW5.8, as well as appropriate SW6 switches depending on socket you want to use, as shown on picture. 1.1 kΩ pull-up resistors necessary for I2C communication are already provided on HDI and SCL lines. Once the switches are turned on. Prior to using EEPROM in your application, make sure to disconnect over peripherals less and additional pull-up or pull-down resistor from the interface line in order not to interfere with signal data integrity. Piezo buzzer. Piezoelectricity is the charge which accumulates in certain solid materials in response to mechanical pressure, but also providing the charge to the piezoelectric material causes it to physically deform. On the most widely used applications of piezoelectricity is the production of sound generators, called piezo buzzers. Piezo buzzer is an electric component that comes in different shapes in size, which can be used to create sound waves when provided with an electrical signal. The AVR V7 comes with piezo buzzer, which can be connected either to PB1 or PD4 microcontroller pins, which is determined by the position of J21 jumper. Buzzer is driven by transistor Q8. Microcontroller can create sound by generating a PWM pulse widening modulated signal, a square wave signal, which is nothing more than a sequence of logic zeros and ons. Frequency of a square signal determines the pitch of a generated sound, and duty cycle of a signal can be used to increase or decrease the volume in the range from 0 to 100% of the duty cycle. You can generate PWM signal using hardware capture compare module, which is usually available in most microcontrollers, or by writing a custom software which emulates the desired signal waveform. Supported sound frequencies. Piezo buzzers resonant frequency, when you can expect its best performance, is 3.8 kHz, but you can also use it to create sound in the range between 2 kHz and 4 kHz. Enabling piezo buzzer. In order to use the onboard piezo buzzer in your application, you first have to connect the transistor driver of piezo buzzer to the appropriate microcontroller pin. This is done using jumper J21. You can place the jumper in two positions, thus connecting the buzzer driving to either PB1 or PD4 microcontroller pin. Buzzer starts singing when you provide PWM signal from the microcontroller to the buzzer driver. The pitch of the sound is determined by the frequency, and amplitude is determined by the duty cycle of the PWM signal.